Welcome back. Today we're going to be talking about equivalent algebraic expressions. Our content objective is students will be able to determine if algebraic expressions are equivalent. Language objective is students will be able to explain how the expressions are equivalent. And why am I learning this? Well, it's important for many math problems like solving equations. Our essential question today is how can two algebraic expressions that appear to be different actually be equivalent? So that's what we're going to focus on today. The key thing is to understand with equivalencies, they will look different, but they can still represent the same exact value. Just in case you forgot, an algebraic expression is basically a mathematical phrase that uses variables, numbers, along with symbols. The difference between a numerical and an algebraic expression is numerical only has numbers in operation, does not include variables. So for number 1 here, it says select all expressions that are equivalent to 2 times the quantity negative 3x plus 6 plus 5x. So the first thing you're going to want to do is simplify the entire expression to see if it's equivalent to the other expressions. And you're going to want to repeat the same thing. If it's not already simplified, simplify it first to see if they are simplifying to the same exact value. So first things first, let's simplify this first expression to see what that gives us. I'm going to go ahead and understand I'm distributing a 2 to a negative 3x and a positive 6. So it's going to be negative 6x plus 12, bring down the plus 5x. I'm going to go ahead and combine a negative 6x with a positive 5x, leaving me with negative x plus 12. So what I'm looking for with the other expressions is to see if they simplify to negative x plus 12. So with the very first expression, I'm going to go ahead and simplify it to see if it does give me negative x plus 12. So here I'm actually distributing a negative 3 to first a 2x and a positive 6. So negative 3 times 2x is going to give me negative 6x. Negative 3 times positive 6 is going to give me a negative 18. I'm going to bring down the plus 5x. A negative 6x with a positive 5x leaves me with a negative x. Bring down the minus 18. This looks similar, but notice this is a negative x plus 12. This is a negative x minus 18. So these are not equivalent. So moving on to B, the B is already simplified. So it's just a matter of, is negative 11x plus 12 equivalent to negative x plus 12? The answer is no. This one has 1 negative x and this has 11 negative x's. So this is not equivalent to the original expression. How about C? So in this case, I'm going to go ahead and simplify first, and then afterwards I'm going to show you something. But I'm going to go ahead and combine a negative 3x with a negative 3x, which is going to give me negative 6x. I'm also going to combine that with a positive 5x, which is going to give me a total of negative 6x's and 5 positive x's, which is a negative x here, negative 1x technically. So I'm writing negative x. Now I'm going to go ahead and combine a positive 6 with another positive 6, which is positive 12. Guess what? These are the same exact value when they're simplified. So they are equivalent. But now something that I do want you to recognize is distributive property is just multiplication. Technically, it means there's 2 groups of negative 3x plus 6. Notice there are 2 groups of negative 3x plus 6, and then in this case, there's just one set of 5x's, so these are equivalent. Now, the best way to really check to see if they are equivalent is just simplify it like we did earlier, but this does show us that it represents the same thing, 2 groups of negative 3x plus 6. And then we're going to add the plus 5x. So this is equivalent to the original expression. What about expression D? Well, expression D, they're exactly the same. So I'm going to go ahead and say that this is equivalent to the original expression. What about part E? Well, part E, I'm going to have to simplify to check if they equal the same value. So let's go ahead and distribute a positive 6 to an x and to a positive 2. That's going to give me a 6x with a positive 12 Let's bring down that negative 7x. So notice it's plus, it's positive. I'm going to go ahead and combine like terms. So I'm combining the x terms. There are more negatives than there are positives, 1 to be exact. And notice I could put a 1 up here. It really doesn't matter. I'm going to bring down the plus 12. Is this technically the same as this? The answer is yes. So I'm going to go ahead and say that E, whoops, let's go back one. E is also equivalent to the original expression. Okay, so for number 2, same idea. We're going to repeat the process, simplify everything that we can to check and see what is equivalent to the original expression. So here we have 3 times quantity, 4x minus 2, then close parentheses, plus 4/10 times the quantity, 4x minus 5. And we have a list of different expressions that we need to choose from to determine if they're equivalent or not. So first things first, we need to simplify the very first expression. So let's go ahead and do that. First, I'm going to distribute a positive 3 to 4x, and here it's just plus a negative 2. So here we have 12x plus a negative 6. Now we're going to repeat this process here. That is a positive 4/10 distributed to a 4x and to a plus a negative 5. So here I can do some side work. This is basically 4 times 4 is 16. Move the decimal over 1 spot, which is basically a positive 1 6/10 x. So I'm going to put plus 1 6/10 x. Here, 4/10 times negative 5 would be basically 4 times 5 is 20. Move the decimal over once. It's going to be a 2. Positive times a negative is a negative, so I'm going to put minus 2. Now I'm going to simplify it some more. I'm going to go ahead and combine a 12x with a positive 1 6/10. Notice here the decimal belongs at the end with the whole number. I'm going to line up decimals with 1 6/10. And that's going to give me 13 6/10. So here we have 13 6/10 x. We're going to combine the negative 6 with the negative 2, leaving me with a total of 8 negatives, so that's minus 8. So when I'm checking to see whether or not the expressions are equivalent to the original one, I want to see if they simplify down to something equivalent to 13 6/10 x minus 8. Okay, so for the first one, that is the option. Is it equivalent to 13 6/10 x minus 8? Obviously, since they're identical, they're obviously equivalent. So I'm going to easily select option A as being equivalent. Now let's take a look at option B. Option B is also already been simplified, except this time it's not minus 8, it's minus 4 6/10. So I can easily say that one's not equivalent to the original, even though the first terms do match up, the second terms do not, so we can say that they are not equivalent. Now for option C, well, let's see here. I'm going to go ahead and simplify this to check to see whether or not they are equivalent. So first things first, let's go ahead and combine like terms. Here is 4x, total of 8x, another 4x gives me 12x. 12x with 1 6/10. Let's go ahead and add that together, 12. Decimal at the end, combine that with a 1 6/10. It's going to give me 13 6/10 x, which matches so far. Now I'm going to combine all the constants together. We have plus a negative here. We can go ahead and plus a negative. Add the opposites. That's what we're technically doing. So how many negatives do we have? We have 2, 4, 6, 8. So that is going to be plus a negative 8, which is the same thing as 13 6/10 x minus 8. Well, is this equivalent to the original expression? I would say so. So I'm going to go ahead and say that C is equivalent to the original expression. Okay, let's check out D. For D, we're going to have to simplify it first before we can check out whether or not they're equivalent. So first things first, according to the order of operations, I am going to have to simplify it within the parentheses first, which I can. 12 plus 12 is 24, so I'm going to go ahead and do 24 times x minus 6 minus 2. Notice this is a multiplication, so you can kind of think of it as distributing 24 times x. It's just 24x. I'm not going to go any further because the x's are all simplified, and that is not the same as 13 and 6/10, so I can stop. But just to prove to you, if I combine these together, we're just adding the opposite. So we're adding negatives. That is going to be plus a negative 8, which is the same as 24x minus 8. Now, even though that these are the same, because the x values are not the same, it is not equivalent. Okay, let's go ahead and repeat the process for part E. So in order to determine whether or not they're equivalent, I'm going to have to simplify. I'm going to combine a 12x with a 1 6/10 x. Hopefully this looks familiar. We've added these two numbers before. They do leave us with 13 and 6/10 x. Now I'm going to go ahead and combine a negative 6 with a negative 2. If it helps, you can add the opposite to kind of see they're just negatives. So that's going to be a plus negative 8, which is the same thing as 13 and 6/10 x minus 8. So are these equivalent? I would say yes, because they're identical, which means these two expressions are equivalent. Okay, so now for part 3. Same exact instructions, but now they've increased the difficulty level with some fractions. So let's go ahead and first simplify the first expression to determine if the other expressions will simplify to the same value. If they do, we know the original expressions are equivalent. If not, they are not. Here we go. So for the first thing, we're going to have to distribute a 3 to a negative 3x and a plus a negative 4. So 3 times negative 3x is negative 9x. A 3 to basically a negative 4, we're going to add a negative 12. Now here, notice we're distributing a negative 4/5. It's so important that you see that it's a negative and not a positive. A lot of students do neglect that negative and it throws off their answer completely, so be very careful. So I'm going to distribute a negative 4/5 to the 3x and to the negative 2. So here we go. That's going to be a negative. Here we're going to do 4/5 times 3, put it over 1. It cannot cross reduce, so it's going to leave me with 12 over 5. So 12 over 5x, can't forget that. We're going to distribute the negative 4/5 to the negative 2. I've noticed a lot of students have forgotten to distribute to the second term, which is a very big mistake. So please remember to distribute to every single term. So we have a negative times a negative. You can kind of see there that it's negative, so that's going to be plus. We're going to go ahead and do 4/5 times 2 over 1 to make them a fraction. They do have nothing in common, so it's going to be 8/5. We can go ahead and combine some like terms. We have a negative 9x with a, here we can add the opposite and count that as a negative 12/5 x. So let's go ahead and do some more side work. Negative 9 over 1 to make into a fraction, plus a negative 12 over 5. 5 is going to be our lowest common denominator, so we're going to have to multiply this by 5, which leaves me with negative 45 plus, this is going to stay the same since the denominator is already a 5, leaving me with a negative 57 over 5. So we have negative 57 over 5x. Now we're going to combine a negative 12 with a positive 8/5. So here we're going to go ahead and write negative 12 over 1 plus 8/5. 5 is going to be our lowest common denominator. We're going to have to multiply this by 5, leaving us with negative 60 plus, well, this one's not going to change, so it's going to stay in 8, leaving me with negative 52/5. So I'm going to put plus a negative 52/5, which is the same thing as a negative 57/5 x minus 52/5, because preferably we only want one operation, one sign. We don't want to see two signs right next to each other. Okay, so we're looking for the expression negative 57/5 x minus 52/5. So taking a look at option A. I'm wanting to know whether or not this expression is equivalent to this expression here. So I'm going to go ahead and simplify what we have. I want to go ahead and first combine like terms with the x's. We have -3, -3, -3. Whoops, let's do a better job circling the -3x. There's -6x, -9x, -12x. Give me a little section for some side work. And we're going to go ahead and combine that with a -12/5 x. So we have -12x. So I'm just going to put over 1. And we're going to subtract 12/5. 5 is going to be our lowest common denominator. So we're going to multiply this by 5, leaving me with -60. Minus here is going to stay a 12. So we're going to add the opposite. This is going to give me a -72/5 x. That's not the same as -57/5 x. So is there any really good point for me to continue on? I'm going to say no and say that these are not equivalent. So moving on to part B. Taking a look. This one's already simplified, so I can just take a quick glance that these are identical. However, the constants are not the same. So I can go ahead and say that they are not equivalent. So the original two expressions are not equivalent. Option C. Well, I see that these are identical as well as the constant here. So I'm going to go ahead and say that these C, the original expression of this here, is equivalent to this expression here. Because again, once it's simplified, they do equal the same value. Okay, option D. Well, let's see. I need some side work here. We're going to go ahead and combine the x values. So this is -9x with, we're going to go ahead and add the opposite here with a -12/5 x. So we're going to do some side work. -9, put it over 1 to make it a fraction. We're going to add a -12/5. 5 is going to be our lowest common multiple. Multiply that by 5, so -45. Here we're going to add, we're going to leave it as a -12 since the denominator is already a 5. So we have -57/5. So far, so good. We have a -57/5 x. Now let's go ahead and combine the constant. We have a -12 with a +8/5. Hopefully this looks familiar to you. We kind of did this in our side work in the very original one, but if you don't remember, I'm going to go ahead and work this one out for you so you can kind of see. We have a -60 plus an 8, which is a -52/5. Are these the same exact values when they are simplified? The answer is yes. So this expression here is equivalent to this one here. So I am going to say D is equivalent. Whoops. D is equivalent to the original. Okay, moving on to option E. So we're going to have to simplify what we have to see if they are equivalent. So let's see. First, let's say -9 minus 9. We're going to add the opposite. So that's basically a -18 times the x minus 12 plus 8/5. We're going to go ahead and multiply these two together. That leaves us with -18x. I'm going to stop right here. That is not the same as this here because the x is already simplified. And since they're not the same, I can say that E is not equivalent. Okay, so guess what? That concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.